Good morning, ladies and gentlemen. I hope everybody enjoyed their snow days the past 2 days. Now it's time for us to get right back on track. So before we had those snow days, we talked about inelastic collisions. We talked about collisions when two objects bounce off one another. We talked about how to solve them, how to set up our chart, and then we did a little practice on them. If you did not complete that practice by today, make sure it is completed by tonight for credit. If it's not completed by tonight, it will be a 0. Now let's talk about our next collision. We're going to talk about elastic collisions. These are bouncy collisions, right? Bouncy collisions. Collisions that once objects hit, they're going to completely bounce off one another. They're not going to stick like inelastic. Inelastic collisions stick. Elastic collisions are considered bouncy. Right? Again, we still have the law of conservation of momentum. And now what does that mean? That means that the momentum before the collision is equal to the momentum after the collision. So let's look at this in a couple examples so you guys will then be able to go off on your own and complete the problems. Example number 1 says the diagram below shows an object of 8 kilograms moving to the right at 4 meters per second. It makes a head-on collision with a 4 kilogram cart moving to the left at 6 meters per second. After the collision, the 4 kilogram cart moves to the right at 3 meters per second. What is the velocity of the 8 kilogram cart after the collision? Well, first things first, I'm going to make this object number 1, this cart object number 2. Now we can go into our chart. Now, for object number 1, we need to calculate the momentum before the collision. Well, it says before the collision, the 8 kilogram cart is moving to the right 4 meters per second. So if it's moving to the right 4 meters per second, we are going to say that we have 8 kilogram cart times the speed. The speed is 4 meters per second. It is going to the right. So we have 8 times 4 is 32, right? We have a momentum of 32 kilograms times meters per second. Now let's look at cart number 2. Cart number 2 says it is 4 kilograms and it is moving to the left now, 6 meters per second. Well, we know anything going to the right is positive, anything going to the left is going to be negative. So let's plug in for the momentum before. Well, our mass is 4 kilograms. We are multiplying that by our velocity, which it's going to the left. So we have a negative 6 meters per second. Well, plugging that in, our momentum, 6 times 4, right? Negative 6 times 4 is going to be negative 24 meters per second times kilograms. Well, now what do we have to do? We have to add all of the momentums before up. 32 plus a negative 24. So basically, you can just say 32 minus 24 is going to give you a total momentum of 8 kilograms times meters per second. Good. Now let's do the momentum after. Well, it says after the collision, the 4 kilogram cart moves to the right 3 meters per second. Well, let's plug what we have in, right? Our 4 kilogram cart. Now it's moving to the right. So that's going to be a positive velocity. Positive velocity. It says move to the right 3 meters per second. Well, multiplying those together, 4 times 3 is going to be 12 kilograms times meters per second. Now, guys, what are we trying to solve for here? It says, what is the velocity of the 8 kilogram cart after the collision? Well, that means we need to solve for the velocity for object 1. So setting this up in our chart, we have P equals still 8 kilograms, right? The mass does not change. But we're multiplying that now by V, right? We don't know what the velocity is. So that just looks like P is equal to 8V. Well, now let's add up the momentum after, guys. 12 plus 8V. You cannot add those together because 12 does not have the variable V in it. So this becomes 12 plus 8V. Good. Now, ladies and gentlemen, the biggest thing with conservation of momentum before always equals momentum after. That equation is on your reference table. So we are going to say PB equals PA. Oh, let me just fix that real quick. All right, now let's plug in. Well, momentum before, right, is equal to 8, and that is equal to 12 plus 8v. Well, I'm going to say let's subtract that 12 over. So we have 8 minus 12, right? Plugging that into your calculator, you're going to get a negative 4 is equal to 8v. Well, let's divide that 8 over. So negative 4 divided by 8 equals v. V is equal to negative 0.5. Negative 0.5 meters per second. And that is your answer. So what is this saying? This is saying that object 1 after the collision is moving 0.5 meters per second to the left. 0.5 meters per second to the left, right? Negative. Anything positive goes to the right, anything negative goes to the left. Alrighty, let's try one more, and then I will let you guys begin working on your elastic collisions worksheet. So we have here a 2,000 kilogram car traveling 20 meters per second collides with a 1,000 kilogram car at rest. It is sitting at a stop sign. At the 2,000 kilogram car has a velocity of 6.67 meters per second after the collision. Find the velocity of the 1,000 kilogram car after the collision. All right. Well, let's find. We are going to make the 2,000 kilogram car object 1. We'll make the 1,000 kilogram car object 2. Let's solve for the momentum of object 1 before the collision. Well, it says that the 2,000, right, that's the mass, 2,000 kilograms is our mass, and it is traveling 20 meters per second. Traveling, oh, my battery's running low, so we're going to hurry up here. Let me plug it in real quick for you. Give me 1 second. Alrighty, we're all good up and running. So we have our 2,000 kilogram part that's moving 20 meters per second. Right, plugging that into your calculators, we have 40,000. Our momentum is going to be equal to 40,000 kilograms times meters per second. Now we need to find the momentum of object 2 before they collide. Well, it says that object 2 is 1,000 kilograms, but it says it's at rest. So is our object moving? No, our object is at rest. There is no velocity. So we're going to multiply by 0. Well, anything times 0 is going to be 0. Adding up our total momentums before, we are just left with the momentum to be 40,000. Good, right? Simple, just like we did in elastic collisions, right? Everything is the same. You just are plugging in what it wants you to solve for. Let's solve for the momentum after for object 1. Well, for object 1, it's right, the mass is still the same. Mass is never going to change. So we have 2,000 kilograms, and it says that it is now moving at a speed of 6.67 meters per second. So we want to multiply those two together. Multiplying those two together, you get a momentum of 13,340. 13,340 kilograms times meters per second. Do not forget that is the unit. Let's find the momentum after for object number 2. Well, our mass is still the same, 1,000 kilograms. We're trying to solve for that speed. So we're trying to solve for 1,000, and then you plug in v. So what we have here is, adding those up, we are left with 13,340 plus 1,000 v. Plus sign keeps disappearing. Now again, guys, we know, right, and I'm going to keep reiterating this to you guys over and over, P before equals P after. So P before equals P after, right? That is the key to doing conservation of momentum problems. So once we have that, now let's plug in what we have. Well, before it's 40,000, and that is equal to the after, which is 13,340 plus 8v. Oh, I'm sorry, not 8v, 1,000v. Now we can solve. Well, let's subtract the 13,340 over. So subtracting the 13,340 over, we are left with 26,660, which is equal to 1,000v. Well, let's divide by 1,000. Dividing by 1,000, we receive, so that's going to equal v. We are left with that v equals 26.66 meters per second. And there you go. That is your answer. Again, guys, remember, momentum is just mass times velocity. So go through and read carefully each example problem, plug in everything that you have, and then we set the momentum before equal to the momentum after. All right, ladies and gentlemen, please make sure you're taking notes on this. Once you are completed watching this video, you may work on your worksheet. Have a great day, guys. We'll see you tomorrow.